So in this case, we are going to consider the introduction to the functional graphs. All right, so you must actually consider working out the whole part of the functional graphs using the playlist. All right, so you're gonna consider the playlist on the functional graphs so that you follow the videos up to the end so that you understand all aspects as per your syllabus, all right, as you are to consider your syllabus. So the first part under the functional graphs is the coordinates. We are going to focus on the coordinates, actually the basics that you need later on as we are going to consider plotting of the graphs, different types of graphs that we have in our syllabus, all right? So as we consider the graph, this is the presentation of what you're going to be using as we have our graph paper. It is something of this nature that we can see here properly. All right, so they are presentations that can be done on this graph paper. A lot of presentations we can draw specific functions, shapes, all right? We can focus with the functions, shapes, which actually is going to affect on our transformation. So all that part is carried or is taken from this graph that we are given here. So when you are to refer to the coordinates as we have here, it is a presentation which is given in this form x, y like this, where you consider the x ordinate and the y ordinate. The x value to the y value. So you start with the x value, focus on the y value, each and every part that you are going to consider in the drawing or plotting of these graphs, always x followed by what? Y. So that's a point that you're given here, which can be represented graphically on our graph here as a point. Let's say we have got a point here, we've got a point here, we've got a point here. That point that you are indicating on the graph, it is taken from the x value, which is always on the horizontal axis, and to the y value, which is always on the what? On the vertical axis, which is the y-axis. So the value that you are given, let's say here, our value of x is, let's say this is 1, 2, 3. I'm going to talk about the scale later on. Then this is also 1, 2, 3, all right? It's the coincidence that these values are the same, all right? Anyways, you consider the x value. You want to focus on this point. That is a point, this one. So at this point, we have the x value, which we need to indicate. As I said, a point is given as what? X, Y, like that. So what is the corresponding x value? That is what? 3. Then you move on to the y value. What is the corresponding y value at that point? That is what? That is a 3 again. So that the point is referred to as 3, 3. X value is 3. The y value is what? Is 3. So this is the idea that you use. All right. So given any condition, guys, let's say here this is 3, 4, 5, 6, and here it's 4, and so on. Let's focus on this point here. You want to know the coordinates of this point that you're given here. So this point, we have to indicate what is the x value and the corresponding what? The corresponding y value to the y-axis. So in this case, the X value first is what? 6. All right. The corresponding Y value at that point here, the one that corresponds is what? Is 4. So we've got the coordinate 6, 4. That's the point. That's how you can indicate a point that you are given graphically. You have a point that is on the graph. What you need to consider is what? The X value to the Y value. So because of different scales that we can be given a scale, different scales that we can be given. When you're given a scale, that is a presentation that you're going to use to indicate values in the x-axis and those values in the what? In the y-axis on our Cartesian plane. So this whole part that we are seeing, the x-axis and the y-axis as presented here is what? Our Cartesian plane. So on the Cartesian plane, you must consider a scale that you're going to use, all right? Which basically is used from the square unit. It is actually taken from what we refer to as the square unit. The square unit is this box here, the first box that we see. It's only that the graph that I'm using, it is just a little bit different in terms of this part that is bold on your graph. It is actually here. So do not consider this. You must have 10 boxes on a unity scale. You must have 10 boxes, which represents 2 centimeters as a basic part of our scale. As the basic presentation, this is the 2 centimeters that you're going to use. And this actually represents to those 10 small boxes. All right, those boxes, the smaller ones, 10 of them. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 2 centimeters. You do not need to measure. Do not measure. You just count those what? 10 boxes. That is what? The 2 centimeters, of which on your graphs that you're using, it's going to be bold, and the lines are going to be a little bit light. And that one that is after 2 centimeters, for every 2 centimeters, I mean, they will be representing them as bold lines. They're going to be bold, all right? But in this case of mine, they are representing after 5 boxes, but it's supposed to be 10 boxes, like up to this. So a square, a unity square is this one, where we have got 10 boxes here in the what? In the x-axis, and these 10 boxes which we are referring in the what? In the y-axis. That is the one that I'm gonna use after 2 centimeters, of which some they can take the unity square as this one, the smaller one, this one, the smallest one, this one. This small, the first is this first box, this one. That is actually basically what you use. But let's consider according to our scale as of our syllabus, we use the basic scale for what? 2 centimeters to represent any unit. So those 10 boxes, which is what? 2 centimeters, they can be used to represent any unit. For an example, you'll be given 2 centimeters to represent, let's say 2 centimeters to represent 1 unit, all right? 1 unit on the what? On the x-axis. Or let me just say both so that we understand. Then I'm going to change, all right? 2 centimeters to represent 1 unit on both axes, all right? Meaning to say the x-axis and the y-axis, we've got both here. So 2 centimeters, we said what? Those 10 small boxes, all right? So meaning to say after every 2 centimeters, after there's 10 boxes, you count 10 boxes, all right? 1, 2, up to 10. You indicate 1. That is, this is 2 centimeters, this one. Representing what? 1 unit, as we are given 2 centimeters to represent 1 unit on what? Both axes. So that is it. So remember, guys, as you consider your graph from this origin, this one is the origin. All right, okay, let me just explain for others to also understand. This is the origin. All right, so the origin is the center point, which is going to give us actually the values which are on the right side, which is on the x-axis, and those ones on the left side, where on the right they must be positive, to the left negative. And from the origin going up in the y-axis, those values going up, they are positive, and those ones below x-axis going down, they are negative values. So meaning to say, according to the scale that I just indicated of 2 centimeters to represent 1 unit on both axes, you are going to have a -1 after those 10 small boxes for 2 centimeters. On the left side, it will be -1. All right. 10 boxes going up, that is going to be 1. Remember, on both axes. 10 boxes going down, that is going to be -1. So that is how we're going to play around. So after every 10 small boxes, you indicate that will be 1 unit. So after every 10, that is another 1. So that will be 2. 1 plus 1. Another 1, that is 3, 4, 5, and so on. So meaning to say the same side here, after that's -2, -3, -4, and so on. So that's the same thing here. 1, 2, 3, and so on. -1, -2, -3, and so on. So that is your Cartesian plan is to be represented in terms of what? In terms of the scale that you're given, all right? In terms of the scale that you are given. So you must understand what you are given on the scale, all right? Let's have another scale. 2 centimeters, let's say they indicated here 2 centimeters to represent 1 unit, all right? Let's say it is on the what? On the x-axis. They can separate on the x-axis, and 2 centimeters to represent, all right, to represent 2 units on the what? On the y-axis. So you can be given different, all right, scales, the one for the x-axis and another one for the y-axis. So in this case, 2 centimeters to represent 1 unit in the what? In the x-axis. For the x-axis, remember that is the one in the what? Horizontal, that is your x-axis. So after every 2 centimeters, after every 10 boxes, you represent 1. So that's 1, 2, 3, 4, and so on and so on. On this side, -1, -2, -3, -4, -5, and so on. All right, that is for the x-axis. But for the y-axis, we are given something that is different. 2 centimeters is supposed to represent what? 2 units on the what? Y-axis. So meaning to say, as we are to indicate values of the y-axis, the one that we have on this vertical line, they are going to be taken after every 2 centimeters, after every 10 boxes, you indicate 2 units. That is the scale, 2 units. So that is 2, 4, 6, and so on and so on. So that is going to be 2, 4, 6, 8, 10, and so on and so on. All right. Then the same thing here for the negative values below. So that's -2, -4, -5. I mean, -6. Sorry for that. -6, and so on. 2 units. So that is 2 units in the what? For the y-axis. For the x-axis, you're given a different scale. It can happen like that. Or they can say 2 centimeters to represent 2 units on both. If it is both, it means we're going to have 2, 4, 6, 8, -2, -4, and so on. 2 centimeters to represent what? 2 units on both axes. So it depends with what we're given. But this one, it was 2 centimeters to 1 unit on the x-axis, 2 centimeters to what? 2 units on the y-axis. just like that. So meaning to say those coordinates can also be indicated from there. Same, all right? So you can now be given a condition where you are the one who is to indicate the point on the Cartesian plane. As I said, you can be given a point. Let's say we have got a point that is here, all right? You're going to state what is the x value and what is the y value. The x value is what? The x value is 2. Here, the y value is what? Is 4. That's a what? That's a point indicated here at this point here. What is the corresponding x? What is the corresponding what? Y value. Now, if you are given the point, let's say you are given to indicate or to represent the point 1, 4, like this. You are the one to represent this graphically on the graph, the point 1, 4. So you simply indicate, all right, you simply consider from the graph, all right, remember the point is given here, the x value, the y value. So the x value is 1. So you note where the x value is. This is where we've got the x value. All right, let me just use a highlighter to indicate that. This is our x value, which is 1. All right, and the y value is what? The y value is 4. So y value is 4, which is positive, and this is 1 here, positive 4. So what happens is that the point is where these two are going to meet. The value for the x, as you're going up, as you can see, you have to move going up to meet with this value for y, and this way, as you can see, they're going to meet. Where they meet, that's you indicate what? That's where you're going to indicate the point. All right, that's the point 1, 4 that you're being asked to represent. So in this case, the point 1, 4 is here. You indicate that. That is the point 1, 4. You mark that with an X. Some they use a plus like this, all right, to say the y value vertically, and this one horizontally for the x like this, you indicate with a plus. So anyway, that you understand. So that is the point. So as you can see, x is what? 1, y is what? 4. So that's how you present a point. You simply consider what is the x value and where the two meet. You can actually use your hands, like you put another finger here, another finger, you take them to one point. Where they meet, you mark a point. All right. So you can do the same. Let's say we are given to indicate the point -1, -2. So the same, x to y. So x is what? -1. Let's indicate x is -1 here. And the y value is what? -2. This is -2 down here. So where these two are going to meet, so you have to take the x value going down and the y value going this side. You can see that they meet at that point. Where they meet, that's the point what? That you are given. Where they meet, where these two meet, you indicate that point. Or like I said, you can just put a plus like this. So that is where the two meet. The -1 and the -2, they meet at what? At that point. So you've indicated the point. So all this is not necessary. You are not supposed to indicate that. All right. So here, this part was just giving us the point. So on the end, this is not supposed to take part, guys, to say is something as if it was part of our calculation. No, the point is the one that we need at the end. So that is how you simply play around. All right. So this is the point -1, -2. This is the point 1, 4. Just like that. X value first, then the y value. So someone can ask, what about the point 0, 2, where the x value is 0 and the y value is 2? So take note, we do not have the x value is 0, guys. So where are we gonna please? Just like here, at this point. So you cannot focus on that. So on this type of a question, you focus exactly on the value that you are given the y value. We do not have anything for x, but we know y is what? 2. So where y is 2, you mark the point. Where is it that y is 2? This is it in the what? In the y-axis, where it is positive 2. So where y is 2, that's where you're going to mark the point here. So that's the point what? That's the point 0, 2. It lies in the what? In the y-axis. The same if it was 0 minus 2 minus 4, 0 minus 2, whatever that you're given. The x value is not given, so go straight to the y value. The y value is what? Minus 2. Mark that point at minus 2. If you are given the point 0 minus 4, exactly at minus 4, mark a point 0 minus 6, that's the point. That's the idea. You do not have the x. The x value is 0. So you take the y value, the one that this that you're given. Y is 2. Since for x there is no movement, so you rest there, direct on the y value. That's the point is going to be indicated, which is opposed when you are given something like this. Let's say the point was now 2, 0 like this. X, Y, remember. So the Y value is a 0. There's nothing that we're going to consider for the Y value. So our focus is on the X value because Y is 0. So what is the value of X? X is what? X is 2. Direct where X is 2 on the what? On the Cartesian plane, on our horizontal axis here, where X is 2. Direct in the X-axis, where X is 2. You mark the point. That's the point what? 2, 0, this one. So that's our point what? 2, 0. If it was minus 1, 0, like the same thing, minus 1, 0. We do not have the y value. What we're given is the x value. X at what? Minus 1. Where x is at minus 1, you mark the point. That's the point what? Minus 1, 0. You mark the point there. That is how you simply play around. So this point simply means it represents what? 4, 0, because it is direct on the x-axis. So it means the y value is what? 0. So the point is 4, 0. This one at 3, it means 3 what? 3, 0. This one, 1, it means what? 1, 0. Just like that. So you can tell that along the x-axis, y is always equal to what? To 0. And along the y-axis, you're going to notice that x will be always equal to 0. X will be always equal to 0, which is part of equations of straight lines that we're going to talk about later on. So these are the coordinates. So understanding this is very important as we are going to use this. So most of you guys, you find it challenging now trying to answer questions. You're asked you to draw a certain graph. You do not know even what is a point, what is the point 14, how to represent that point 14. You cannot answer questions on graph if these basics are not understood. So I want you guys to go through these basics, all right? Where you do not understand, we have the comment section. Let us communicate so that we can work on that part again. But for now, that is it till we meet again.